Let's look a little deeper into tracing references and also how privacy leaks happen, even when the instance variables are private. So an example I'm going to use here is a class called a book. A book has a name. I'm just keeping it really simple. We're just looking at a trace. So there is a single constructor that takes the name as an argument and a getter method for the name. So if we create, so I have here my heap. Remember, the heap is where all the objects are created and stored. There is some objects on the heap, they're not relevant to this example, just shows what the heap looks like. So I'm looking at this one line of code that says create a new book, and the first thing that will happen is it goes to the heap and asks for space for a book. It puts 1 as the name, and there will be some location. So I randomly chose a number 29. And that 29 is the reference. Okay, so that's the memory location on the heap. We also have a stack. If I'm assuming that this is sitting in some kind of a method, then we also have the stack to work with, and that is where our local variables go. So all local variables go on the stack. So the B1 is of reference type, and it has location 29, and that is all that is stored on the stack. It's a reference, location 29, and the name of the variable. So if I now say that there is a book B2, again, I'm creating a variable. The variable is a local variable. It's going to be put on the stack, and it gets the same value as B1, and I copy the data that is on the stack, namely the value 29, and it's again a reference. So let's see what happens with a primitive. It's kind of the same thing. It's a local variable, so it ends up on the stack. Its type is an int this time, not a reference. It's a primitive type int, and its value is 7. The moment that I say B1 is a new book, I see the new keyword, we'll go to the heap, we'll get space for it. In this case, it ended up on location number 11. So now it says B1 is equal to wherever that is on the heap, namely location 11. So the stack is updated such that B1 is referencing 11. Again, this makes no difference to B2. So when I did an assignment statement, and there's no new involved, I copy the stack data. Whatever data is on the stack is simply copied over. When I have the new keyword, I create a brand new instance on the heap, and what I get back is a reference to it, its memory location. So what if an instance variable is a reference type? You know, I'm creating a second class, a series. So we're looking at a book that had a series of books. So an object that captures that. And inside of it, there is a list of books. And the way that a simple way of doing this in Java is using the ArrayList class, which is in java.util, the package, and then indicating with the angle brackets that what I'm storing inside of the list is of type book. And the name that I'm giving to the variable is books. And then I have an add method, which does what you would expect it, and a get method, and I'm providing the number of the book, which is really an index. I can also get all of the books, and it will return the entire list. So it just returns the instance variable books. All right, so if I'm creating a new series, remember that when I'm creating a new series, I'm going to the stack. The interesting thing here is that inside of that code, there is also a new array list being created. So I'm creating another object sitting right in here. And my series, the green one, has a reference to that. So it has an instance variable called books. It's of reference type, and it's at location 32. Okay, so that is in my green one. So I now have a list, which is an array list, which is sitting in the gray box, and a series, which is sitting in the green box. And as before, on the stack, S is a local variable, so it's of type reference, and it's looking at the green box, which is at location 58. So if I now add a book to this, so I'm adding B1, I'm going inside of the methods I'm going inside of S. From there, I'm going to go inside of the books reference, and I'm simply adding it, which is doing what you would expect it to do at location 0. It's going to copy over the reference, that B1 has stored inside of it. So it's the 11 that gets copied over, and that will sit inside of the array list. Add for B2, I'm going to do exactly the same thing. It's a reference to 29. The B2 was passed in, so when I'm passing it in, I'm passing in the value 29, and that gets placed into the list. So now if I do a get all, I am going to get back the books, the reference of 32. So I'm going to get back the reference. So AL, array list, is a reference type, and it's looking at location 32. So this here is known as a privacy leak. Notice that I have an object sitting inside of my series class, which has a reference at 32, but somebody outside, namely on the stack, also has a reference to exactly the same object. But I meant it to be private. Okay, those books, that list of books was meant to be private. So this is another way of looking at it. I have a privacy leak. Somebody else has a reference to my private data. The same happens with the reference to 11. It is sitting inside of that list. It was meant to be private, but somebody else has a reference to my private data. It's also a privacy leak. So just to recap, a reference is copied for assignments, parameter passing, and returns from methods. Always a reference, always the reference, or whatever you would see stored on the stack. An object is copied only if we explicitly do so. If we create a brand new object explicitly, then the entire object is copied. Otherwise, we just get the reference. So just to start with, how do you make sure that there is no privacy leaks if that is indeed what you want to do? So if I look at this here, the add method, it takes as an argument a book. So whoever calls this method has a reference to exactly the same object because it's passing the reference in. And now what I'm doing is I'm, instead of using that reference and storing that, one thing that I can do is, why don't I just create a copy of the book that I'm being passed in as the reference? And that way I have a brand new book, nobody has access to that, and it's actually private. So instead of using the book directly, I could use the copy constructor to make a copy of it. And this is assuming that the book class has a copy constructor, and which is why I recommend that every class has a copy constructor inside of it. So looking through that fix, I will have gotten rid of one memory leak. So I'm just going to walk through the trace again. So if I go to my series and I add B1, so I go to the add method, I have there being passed in B1, which is a book. So a book now gets a copy of that reference, namely 11. The next thing I'm going to do is I'm going to do create a new object. The moment I see new, I'm going to get myself a nice little box. Since it's a copy constructor, it should copy the data, but it's a brand new one. It will also have it will have its own reference. So that's whole thing evaluates to the reference 82, and the reference 82 is what is going to be added into my green box, the list. So that is going to have the value 82 in it. Because the method is now done, that local variable a book, which is a parameter, is removed from the stack. I'm done with it. And this is what this will look like. And the same thing will happen for if I'm adding B2. I'm making a copy of B2 and adding that copy to the list. So now notice that I have basically prevented the privacy leak. If I'm looking at my gray box, I have references 57 and 85 in there, which don't appear anywhere else. Okay, so now I've truly encapsulated that data. Almost. Because look at the get all method. It just returns the books. So what is AL going to have is that reference 32 is being returned. So I still have a privacy leak sitting right here. And it's an exercise to look at how would you remove that privacy leak.